Good. Hello class. This is our presentation of our iteration 1 for our software engineering project with team members Ashley, Joel, and Nathan.
Hello.
And speak more loudly because of the microphone.
Our product that we are going to develop is a calendar application that will be able to save, create, and modify study events. This is specifically for students who want to organize their schedule. It's more of an electronic planner, so you will be able to log multiple study sessions, and on top of that, you will be able to, once you have received a grade for an assignment, whether it was for an exam or for a singular homework assignment, you'll be able to log your progress by being able to save results after they have been released.
These are the functional requirements that we've decided on. First, the user should be able to create a study session in their application.
Loudly.
Next up, they should be able to delete any study session that they create just in case events change. And speaking of change, they should be able to change the study session in case, an assignment ends up taking longer than they thought, or maybe they finish sooner. It displays sessions in 2 distinct organized formats. We'll get to that later. It should be able to save any events that you make. So when you close out of the program, when you open it up again, like a day later, it should be able to remember what you put in the day before, and it needs to be able to keep an accurate calendar so you don't end up with something like July the 42nd.
And the last 3 that we decided on were non-functional. These are a bit broad, but they are required. For the creation updates, this is for when you create a new study session. The system needs to update the UI, needs to save this current session. And we wanted to have a baseline for how efficient we want that to be. So we agreed on a baseline of 2 seconds for the from hitting go to creation for the UI to be updated. The other one was mode efficiency. We're going to have 2 visualizations, 2 modes for our program. There's going to be a list format and a timeline format. We want to be able to swap between these seamlessly, and we want the swapping to take at most 5 seconds to be efficient. And the last one is for system updates. This is more for when you change something, you update the name, you update the time, you update the result. We want that as well to take 2 seconds for us to be sure our program is running efficiently.
Okay. There are 3 main actors: the user, the program itself, and the operating system. The user, of course, controls everything. They add events, delete, change them. The program runs the operations that the user wants, and the operation system is kind of an assistant to the system program. It's the operating system is where it keeps the created study sessions. Whenever you close it, it saves them to the operating system, and also where it gets information to create the calendar.
This is one of our use cases, which is creating a new study session. So the user will first press a create button on the list format view of the calendar, and this will prompt the program to display an empty study session that they can then enter the details like the name and the time of this session. And then when they exit out of the creation mode, it will prompt the study program to save that session and then update all of the calendar views. And another use case is for deleting study sessions. So similar to the user will be in list view, and they will press the delete button on the study session, and the study program will then verify. There'll be a window that will pop up making sure that the user wants to delete that session. The user will then confirm, and then the study program will save that deletion and update all of the calendars.
And another one will be for saving. So the user will want to create a new study session. This is from our previous use case, and it will generate the event, but then we need to save that event in the OS as a text file of some format that can be then accessed later. This is very important for us to be able to open the program multiple times and have the same outputs.
Skip over.
And our final one will be able to change the time. This is very important because by changing the time of an event, that could possibly change the UI. And so we need to be able to handle this case efficiently, because by changing an event, you could also be moving it further down the timeline. This is our traceability metrics to organize our use cases and requirements.
Okay, these are the user interface sketches. This one is what you first see whenever you boot up the program. It obviously isn't going to have all 35 of those boxes there. It's going to change depending on the month. And then when you click on a specific day, it brings this up. This is the list view for the study session. So here you have the title. This X is the delete button. These are the time as displayed in a numerical format. An edit button over here, you add it with this. Back to calendar, and 2 arrows to shift between adjacent days. And then when you press on this button, it pops up as a timeline. Now you can't edit events while on the timeline. This is more for a convenience thing. But the way it is it's a long bar with markings of the time along the top. And these shaded in areas are study dates. What we're planning on is when you mouse over these shaded areas, it will show you exactly what it is.
And this is our domain model that we've come up with so far. Basically, we just have a calendar that holds all of your dates and study sessions, and each study session will be on a particular date.
And this is our tentative routine work plan with our schedule, where we're going to be working through iteration 2 and then finally iteration 3 with the projects laid out in a different color to delineate our delivery date. And that is our presentation for iteration 1. Thank you for coming.